Hello all. In this lecture we will see about retrieval queries in SQL. So SQL has one basic statement for retrieving information from a database. It is a select statement that we use. So it is not the same select operation of relational algebra, we have already seen that, but it is different from that select operation. So this is entirely different. Don't be confused with that relational algebra select operation. So this is different. So we can write any retrieval queries using this select statement. From basic to very complex, from very simple to very complex queries can be written using this select statement. So this is the outline of this lecture. We'll see about select from where clause. Then when we have ambiguous attribute names, what should be done, and also alias, how to rename or give some other different names for the same table and do all these operations. So select from where clause. Select from where clause is the basic retrieval query that is being used. So if whatever data information you want, you can use this statement to retrieve information. So this is a general syntax for that. Select and attribute list will be given. This angle brackets is not there, so you have to replace with this, the whole thing is with the a list of attributes. So which all data you want to retrieve, that will be mentioned here. Then from the table list or the relations, which all tables, from which all tables you require this information. So it may be a single table or from multiple tables you require those data. Then you have to specify in commas, separated by commas. Then where, and we will state some condition. Okay, so this is a general syntax for select from where. So select attribute list. So attribute list is a list of attribute names whose values are to be retrieved by the query. Then table list is a list of the relation names or the tables required to process the query. So from which all tables we require this data. And condition is a conditional Boolean expression that identifies the tuples to be retrieved by the query. So it is based on this condition, we will select those attributes and we will be list out from these tables. Okay, so in this way we can do this. And one thing to notice, we can have any of these relational operators in this condition. So these are the relational operators: equal to, less than or equal to, greater than or equal to, and this is not equal to. Okay, this is a symbol for not equal to. So when you have studied C or any other languages, you might have not used this symbol. So you might have used some exclamation mark and equal to, like that. So here less than and greater than symbol should be given for not equal to. If you want to specify there's some condition not equal to, then you have to use this operator. Okay, so that's the only change in this queries or in the relational operators. So we will see some example queries. So this is the database that we'll be using. So we have already seen we will be using employee, department, department locations, project, works on, like that, dependent, all these tables. So this is the basic table that we'll be using. So example 1. So we have to retrieve the birth date and address of the employees whose name is John B. Smith. So we want to retrieve birth date and address of all employees whose name is John B. Smith. So if we go into the table, we know birth date and address in this table. And John B. Smith also, that information is also in this table. So we require only employee table. So with using this employee table itself, we can retrieve the information. Okay, so the query will be like this: select what all things we want. So attributes are b date and address. So b date comma address from which table? From employee table. And what is the condition? The condition is name is this. So name means this is first name, this is middle initial, and this is last name. So where f name equal to John and middle initial equal to B and last name equal to Smith. Okay, so this way you can specify this query and the resultant will be like this. So you'll get a table like this. Okay, I'll show that example. So I have already written this query. So we have already seen this thing. So you can retrieve using the same thing. So this is the table. So select birth date, address from employee where f name equal to, sorry, so f name equal to Arun and middle initial equal to M and last name equal to Shashi. So there is a person like this. So you can retrieve this information. When you run this query, the table will be retrieved. So one birth date is this 15 October 85 and the address is like this. Okay. So in this way we can retrieve information from the table. So using this select statement we can use this. So we will get a table for, we will get a relation in this format. Here birth date and address are known as projection attributes. So we call this as projection attributes. So these attributes are known as projection attributes because we want to project the data from these attributes. So these attributes are known as projection attributes, and this condition is known as selection condition. So this condition is known as selection condition. Okay. Then we will see another example. Example 2, it is retrieve the name and address of all employees who work for the research department. So we have to retrieve the name and address of all employees. So name and address is in this table, and who works in research department. That department name is not in this table. So that department name is in this table. So we want data from these two tables. So we have to include employee comma department. Okay, so we have to include employee comma department. So this is example 2. So what we have to do is we have to include, we want first name, last name. So if you want middle initial can also be included. I am taking only first name, last name and address from which all tables employee and department, because research name is in department. Now what is the condition? We want to find all the people in the research department. So what is the condition? So where D name equal to research, that is department's D name should be research, and this D number equal to D number. That means this department number and this department number should be equal. So if if the research department is 5, then all the employees who are in department 5 will be retrieved. So that means we will get the resultant. Okay. So in this way we can retrieve information from the table. Okay. So this is the query. Select first name, last name, address from employee comma department where this D name equal to research, and there is a join condition. So we have to join those tables, then only we will get the result. So this will be the resultant. So first name, last name and address will be displayed. So this D number equal to D number is called the join condition. So this is known as a join condition. So we will be joining those tables. Then only we will get the data. Then only we will get the data. We can find out which all employees are there in the research department. So D number equal to D number is the join condition. So this D number is the employee table and this is in the department table. So we call it as select project join query. So this is known as select project join query. Okay. So next we will see another example of select project join query where we have two join conditions, where we specify two join conditions. So this is a query that we want for every project located in Stafford. So you know that project details are in project table. List the project number, so that is also in the project table, then the controlling department number and the department manager's last name, address and birth date. So department manager's information is in department table and this name, address and birth date is in employee table. So we have to join employee, department and project. So based on this project number, project location, so Stafford, so that is the project location. So based on this project location, we have to find the manager who is a manager of which all projects are in Stafford, D num equal to D number. Then what basis we have to list the managers. So we have to equate this manager SSN with SSN. And from that we have to retrieve the information of the name of those employees. Okay, so in this way we have to do that. So the query will be select P number. So we have to list all the attributes we want. So P number is required, then D number is required. So we want to list the project number, then the controlling department, that is D number, then the last name, the manager's last name is required, L name, address is required, and birth date is required. From which all tables? From project, department, and employee. And what is the condition? Where D number equal to D number. So this is in the project table. Okay, so this D num is in the project table and this D number is in the department table. And which is another condition, manager SSN equal to SSN. So we have to equate with the employee table. And also one more condition is there. We have to get only the projects of location. P location is Stafford. So this is so we have we have two join conditions here. Okay, so actually we have three join conditions here. Okay, actually three join sorry, two join conditions. We are joining two tables, so there are two joining. So this is D number and D number is a join of project and department. Then this is the join of department and employee, and this is the information that we want. So this is not project join condition. So the join conditions are first one and this is second one. Okay. So this is the resultant table. We will list out P num, D num, last name, address, and birth date. So this is the information. So the two projects are located at Stafford. And this is the last name of the person who is the department manager. Then next is ambiguous attribute names and aliasing. So there may be possibilities of ambiguous attribute names. For example, if we use this retrieve the name and address of all employees who work for the research department. So we have already seen this query. So we have already written this query. Select first name, name. Okay, we will see that example first. So we have to retrieve. Let me take this one. Sorry. So what information we retrieve the name and address of all employees who work for the research department. Okay, so research department is in a department table. So this information is department table and name and address in the employee table. So we are joining these two tables. So imagine that here instead of this first name, middle name, and last name, we are using a single attribute and the name of that attribute is name, NAME. So we are using this name of the attribute of employee as name instead of F name, middle initial, and last name. And similarly for department, we are going to name it name itself. So what happens is we are joining two tables which are having the same names for the attributes. So we are trying to join employee name, and also in this department we have the name. Instead of D name, we will be giving it name. So imagine we have already named the attribute as name. Instead of D name, we are naming it as name. And here instead of all these three attributes, we are using a single attribute called name. Then when we join these two tables, there will be an ambiguity because the SQL or the database doesn't know which name it is, whether it is employee name or the department name. So if we have such a condition, so I will show that example. So if in that case, this will be the query that will be written. Okay. So in that case, this will be the query that will be written. So first name, so instead of last name, we are giving it as name. Okay, I have not mentioned. So F name, instead of last name, we are using the word name itself. So imagine that the table, we have named that instead of last name, we have used the name attribute. And here also from employee department, and here we have used the department's name also as name. So here what happens is there is an ambiguity. We don't know which is this name and which is this name, whether to list the department name or to list the person name. So there is an ambiguity. Similarly, if we are using the same name for department number also, so we do not know whether this is employee department number, and this is department number. So we are not able to locate it. So this is known as ambiguity in attribute names. So if this is the case, if we have same names, then there is another method to write this query. So we can specify like this: f name, comma, we will specify employee dot name. So this means this name belongs to the employee table, and also we can specify like this: department dot name equal to research. Instead of specifying name, we can use the table name also, table name dot name, and we can specify like this: department dot d number equal to employee dot d number. So in order to avoid this ambiguity, so if we are using same names for the attribute in two different tables, and if you try to join those two tables, then there will be ambiguity when we specify this condition and all. It will be very difficult to understand which this name denotes, or which this department number and which is this department number. So in order to avoid that, we can use like this: employee.name, department.name, like that, department.number. So this is known as renaming, or we call it as aliasing also. There's another method also, we call it as aliasing. So this is actually one way to specify this at naming. Another way is aliasing. So we can alias it. I will show it later. So this way also we can specify. So we can write the queries like this: instead of giving the short only the attribute name, we can specify like this: whatever retrieval you use, wherever you use, you can specify the attribute name like this: table dot that attribute name. So employee.f name, employee.tail name, employee.address, like this, department.t name, and department.t number, employee.t number, like that you can specify. Then there won't be any ambiguity. So in this way you can write also. So you can write the same queries using like this. Okay, instead of specifying the attribute name alone, you specify the table name also. So if you want to retrieve for each employee, retrieve the employee's first name and last name, and the first and last name of his or immediate supervisor. So this is another example. So if we want to specify retrieve an information, that is employee's first name and last name, and the first name and last name of his immediate supervisor, that is, we want to list the employee name and also the supervisors and his or her immediate supervisor's name. So we are trying to join employee with employee itself. Then there will be a problem. So what we do is, here we can do this aliasing. So we can do this aliasing. So in this case we can do like this: employee.f name, department.e name. But here we are trying to join same tables. Employee and employee are joining, and we are trying to retrieve the same information: first name and last name of employee, and also the supervisor's first name and immediate supervisor. So if you take this, what we are trying to project is employee's first name and last name, and also supervisor's first name and last name. Then there will be an ambiguity. So in order to avoid that ambiguity, we can use this another way to represent this, that is known as aliasing. So what we do is, we will give aliases for that relations. So what we do is, we are aliasing employee as E. So this is a keyword that is used as employee as E, and employee as S. So we have created two different tables. It is like two different tables now, E and S. Actually, we are not creating any tables, new tables. We are simply giving new names to the table. So employee table, we call it as E, and for the supervisor, we call it as S. Now what information we want to retrieve is the employee's first name. So E.F name, comma, E dot last name. And similarly, we want to list first and last name of his immediate supervisor. So S dot F name and S dot last name, where this is the condition: E dot super SSN. So employee dot super SSN equal to S dot SSN. So in this way, if we specify, then we can retrieve the information. So this is known as aliasing. So we are renaming those relations. We are renaming that relations as E and S, and we can specify this. So if it is the same table we are joining, we can use this aliasing method. Another way we can alias, instead of writing this employee as E. If we want to rename all the attributes also, it is possible. So simply after that we have to include this whatever it is there in the brackets. So we are simply renaming all the attributes of E table. That is first name, F name is changed to FN, MI, LN, like that we have given some other names. Then you can write, instead of writing E dot F name, you can simply write FN, because we have renamed the attributes also. So we have renamed all the attributes. So this way also we can do this. So this is aliasing plus renaming of all the attributes. So we have already seen in relational algebra that there is a rename operation. So in this select operation itself, we can specify this renaming. So we are aliasing it, we are giving some other name, and in brackets we rename all the attributes. So now on, we can use these attributes also to specify the employee table. Okay, so that is also possible. So this is known as renaming. So after that, the result will be like this. So we will get E dot F name and E dot last name, and this is supervisor's first name and supervisor's last name. So John Smith supervisor is Franklin Wong. Like that, we will get the information. So this is another example for aliasing. So we have already seen this query: select F name, last name, address from employee and department, where D name equal to research and D number equal to D name. So if you want, you can rename this also like this. If you want to shorten the names, it is possible. So we simply give as employee as E and department as D. Then we can use like this: D dot D name equal to research, D dot D number, E dot F name, like that. Instead of writing employee dot F name, employee dot last name, we can simply write E dot like this. So if we want to do that, we can do this aliasing. This is known as aliasing. We can alias the, or we can give other names for this relations using this as. Okay, employee as and department as. Now next topic is unspecified where clause. So in all the examples we have seen that we are specifying this where clause. So what happens if we are not specifying this where clause? So this is an example. So if there is a missing where clause, it indicates that no condition on tuple selection. So there is no condition for this row selection. So if there is no where clause, means there is no condition for this selection. So everything will be found out. So every rows or every tuples will be returned if there is nothing. So all tuples of the relation specified in the from clause qualify and are selected for the query results. So if you are not specifying nothing in the where clause, then all the rows will be displayed as output. So if more than one relation is specified in the from clause and there is no where clause, then we get the cross product of these selection. Okay. In the previous case, it is like a join case, a join condition. Actually, it is what is happening is join operation. If you are specifying that where condition, then it is join operation. If you are not specifying this where clause, then it is actually cross product. If we are joining two tables, if we are trying to take something from some data from two tables, then and we are not specifying any where clause, means it is actually cross product that is happening. We take the cross product of those tables and the whole both the table values will be listed as a result. So this is an example. So if you are specifying this, select SSN from employee. So this means all the SSN from employee table should be listed. Or if you are specifying like this, SSN comma D name from employee department, there is no where clause. So what it returns is all the SSN values and all the D name values will be listed. And what we do is employee cross department will be taken here. So all the combinations will be listed as output, all the combination. So this is an example. So SSN, so 1, 2, 3, these are the SSN values and all the D names. So we have three departments actually: research, the administration, and headquarters. So these are the 8 employees. So all the 8 employees combination. So this is actually cross product that is happening. This is another 8 employees in the administration. This is another 8 employees in the headquarters. So when we specify like this without where clause, here cross product is taken. Okay. Then use of the asterisk. So what is the use of this asterisk? So if you are specifying select asterisk from employee where department number equal to 5. So if we specify something like this, then all the attributes or all the columns will be listed. So we are not specifying any attributes here. Instead of specifying the attributes, we are specifying asterisk or star. So this means all the attributes should be listed. So we are selecting all the details of employee who are working in department number 5. So we will get everything. So all the columns will be listed and with its condition department number equal to 5. Then we can do like this also, select star from employee department d name. So this is the same operation. Here we will be listing all the details of all the attributes of both these tables, employee and department. All the attributes will be listed which satisfies this condition. Then select star from employee. So if we write something like this, then all the elements will be listed. All the 8 rows which are there with all the attributes will be listed. So we are not specifying any where clause here. If we are not specifying where clause, then all the rows will be selected. And if you are specifying like this, select star from employee department, this means that cross product will be taken and the whole attributes will be listed. So this is the reference. So thank you.